Hello. Today I'll be explaining round 119 questions 4, 5, and 6 of the grade 8 and under Prairie Math League problems. So I guess I'll just get started then. Okay, here, question 4. Basically it reads, let A be the least natural number with the following property. 10 times A is a perfect square and 6 times A is a perfect cube. How many positive divisors does the number A have? Okay, firstly, let's just find the prime factorization of 10 and 6, right? Like 10 is obviously equal to 2 times 5, and then 6 is equal to 2 times 3. We know that for a perfect square, the exponents of all its prime factors has to be an even number, right? It has to be divisible by 2. And for a perfect cube, the exponents have to be divisible by 3. Okay, so firstly, to fulfill the first requirement, we know that A has to have at least 1, 2, and at least 1, 5, right? But like secondly, then for to fulfill the perfect cube requirement, we also know that A has to have at least 2 3s, so that 6 times A would have 3 to the power of 3, which is divisible by 3. And then it also needs 2 more 2s because, you know, you also want 2 to be like, to have an exponent that's divisible by 3. And then you also want 3 5s because there's no 5 in 6's prime factorization. But the problem here is once there's 3 2s, like you can see that like with the 2 2s added, like if you add 2 2s to 2 times 5, you'll see that 2 to the power of 3 isn't actually divisible by 2, right? So you need another 2. So then it's 2 to the power of 5, right? Because this one has 2 to the power of 1, and this one has 2 to the power of 1. 1 plus 5, that's 6. This is divisible by 3 and 2, right? And then that's times 3 to the power of 2, right? Because there's already a 3. You add 2 3s, that's 3 to the power of 3. This one has no 3s. You add 2 3s, that's 3 to the power of 2. In either case, it's divisible by like 3. And yeah, in either case, it's divisible by 2 and 3. And then you have 5 to the power of 3, right? Because there's 5 to the power of 3 when you multiply 6 by A, but then when you multiply like A by 10, there's another 5 in 10's factors, so it's 5 to the power of 4, so it also fulfills both requirements. So this is the n prime factorization of A, and to find the total number of factors, it is 5 plus 1 times 2 plus 1 times 3 plus 1. Right, that's how we find the total number of divisors, and then that you do the calculation, right, and then it's just 72, which is D. Okay, going on to question 5 then. Okay, so basically a beam of light shines from point S and reflects off a reflector at point P and reaches point T so that PT is perpendicular, and we want to find X. Firstly, let's extend PT to the bottom here, right? Because it's perpendicular, it forms a 90-degree angle. Then we notice that X and this angle would be the same because they're vertical angles, right? So this will also be X, right? And then we find the measure of like this angle here, this total angle. So that's just 180 minus 90 minus 26. That would be equivalent to 64, right? Like 2x is equal to 64. X is then equal to 32. So the answer is B. Okay, going on to number 6 then. A gumball machine contains 11 red, 12 white, and 15 blue gumballs. The least number of gumballs a person must buy to be sure of getting 4 gumballs of the same color is. Okay, so like the assumption there is that we need to have, like, firstly, like you want to buy up 3 gumballs of each, right? Like once you buy up 3 gumballs of each, right? 3 times 3, that's 9. Once you buy up 9 gumballs, assuming that you're really, really unlucky and you only have 3 like gumballs of each color, then the 10th gumball, you buy has to be one of the 3 colors. So that's just 9 plus 1, which is equal to 10. Okay. That concludes today's explanation. Thank you. Bye.